This is the story of a warehouse that was designed for a group in the distributive trade. But it is no ordinary warehouse. The emphasis is not upon storage, but distribution, with the movement and flow that this implies achieved by using standard handling equipment, but under the direct control of a computer. The Automated Regional Distribution Centre of the Cooperative Wholesale Society at Berkeley in County Durham is a development of note, an important break with traditional notions of warehousing and a signpost for the future. Here is to be found much new thinking and advanced technology. There are many problems with old warehouses: hygiene, labor, access, pilfering, stock turn among them. The main activity is order picking. Goods required for distribution are selected by hand, one order at a time. Errors occur because people are inefficient at such routine jobs. All the while, increasing demands on distribution call for larger and faster throughputs, which in old buildings leads to congestion. The overall system into which warehouses fit may also be such as to make it difficult for them to function properly. Consider an instance in which several large warehouses draw their supplies from a number of factories and distribute them to the local warehouses that serve the shops. If, as is commonly the case, the local warehouses and the shops can also draw supplies direct from further up the chain, the net result resembles the web of an intoxicated spider, overblown and expensive. The designers of the Berkeley Centre faced such a situation and saw that many of its obvious shortcomings arose from duplication of function and route. Indeed, the system was so bereft of opportunity for improvement that the planners decided to scrap it and start again. Studies showed that, in this case, a regional distribution centre with full automation would give an improved service and at a lower operating cost. Transportation could be rationalized by having everything flow through the one centre. Emphasis was placed on movement and flow of goods, on distribution instead of warehousing. It meant, in the end, running the distribution centre by computer. Today, the regional distribution centre is in operation, capable of handling £40 million worth of goods a year. The centre can accept 2 tons of goods a minute, sort them into orders for the shops, and dispatch at rates approaching 5,000 cartons an hour. 3,500 lines are stocked. All this has been achieved by the use of established techniques in novel configurations. The computer is an off-the-shelf model cleverly applied to materials handling. This is the real innovation. The designers faced some intricate problems in arriving at their final design. All warehouses bear certain resemblances. There must be an area for the receipt of goods, another for storage, and a third for dispatch. There must be space, too, for services and offices. The relationship of the areas to one another should be such as to allow for the easy movement of goods. The main problem in designing fully automated systems is that goods are not uniform. They vary in size, weight, shape, value, and in quantity handled. Throughput could be optimized for every line stocked, but this would mean a separate system for each line and much more equipment. It is necessary, therefore, to identify groups of lines with characteristics in common. At Berkeley, there are 4. First, the high user lines, which feature in every order. The number is low, but the volumes handled are high. Second, the low user lines, a wider range of goods, but smaller volumes of each. Third, the small lines, small quantities of a very wide range of goods. And fourthly, specials such as bacon, with exceptional volume or requiring special storage conditions. In the center, the groups are allocated space according to the volumes handled. The high user group, naturally, occupies most of the space. Low user lines fill the remainder of the high-rise store, while small lines and specials have separate stores. Full automation is employed for the high and low user groups. Small lines and specials are handled by more conventional methods. Lack of uniformity between lines makes order picking a considerable problem of automation. The task involves handling lines in a variety of packages, sometimes whole cases, sometimes minimum outers only are required. To achieve this by machine would obviously be difficult, and the flexibility of human operators is attractive. It was therefore decided to retain operators for picking, even in the high user store, but to make their work easier, goods are presented to them automatically. Information about the number to be picked is given, and a check is made to ensure that the operation has been performed correctly. The layout of the systems in the center is such as to facilitate the rapid movement and flow of goods. Separate systems are provided for high user, low user, and small lines. Incoming small lines are pushed through into the adjacent warehouse. Low user lines are placed on a conveyor that leads to their own store area. The high user system is fully mechanized with automatic repalletizers feeding goods onto an input conveyor. This forms a loop with spurs leading to elevators and so to the main store. This main store is built high to give maximum capacity on a limited area. Goods are accommodated in racks which form a three-dimensional grid throughout the store. Special stacker cranes are provided in the aisles between the racks to collect incoming goods from the elevators and place them in the racks. The cranes also retrieve goods from the store and take them to the elevators that lead to the carousels. These carousels present the goods for picking. At this point, operators perform the picks and the goods are taken by conveyor to the order assembly tables where they are sorted mechanically into the quantities required for each shop. Small lines are added before the orders are wheeled straight into waiting trailers. Bacon is handled separately and added to outgoing orders in the dispatch area. The entire operation of the center is both controlled and directed by the computer. The computer is a standard ICL 1903A digital machine, which is used not only for the physical control of the machinery in the center, but also for the paperwork involved. Output is by line printer on the commercial side and by an MEL warehouse interface unit for control of the center. The process begins with the shop managers marking their orders. These are fed into the computer. The computer processes the orders against the overall stock position and fixed delivery arrangements. A plan of campaign is drawn up in the computer to control the machinery that retrieves the goods from the store and sorts them into orders for delivery. Meanwhile, the associated paperwork, route schedules, van allocations, and dispatch notes are printed out to control the distribution of the goods to the shops. It is through the warehouse interface unit that the computer controls the machinery in the center. This receives data from the center about the location and nature of goods and transmits commands to the machinery in real time to progress the goods through the center. Thus, the computer is able, by time sharing, to work out the master plan for the assembly of orders and to put these plans into effect by the exchange of information and commands in the form of signals received from and transmitted to the machinery. Additionally, of course, the computer is used for stock control, forecasting, invoicing, and all the many other clerical duties associated with distribution. The small lines system is run more or less conventionally, and as such provides an example of computer control at the lowest level. A list of small lines required for a current group of orders is printed out by the computer in the form of picking lists. Goods are picked into standardized rolltainers, which are then wheeled straight through to the dispatch area, where they are incorporated into the orders being assembled from goods arriving through the other channels in the center: high user, low user, and specials. High user lines arrive at the center by the lorry load, and much is already on pallets. In the center, another type of pallet is used. It is called a platen and is 1.4 meters square. These platens are designed to fit the conveyors and racking, so all loads must first of all be transferred onto them. This is done by machine in an automatic repalletizer. Two such machines feed the input conveyor. Clamps on all four sides of the device tighten a stack of goods on the pallet to aid its passage through the storage racks and elevators. While it is held firmly, the stack is tilted to the horizontal position, where the pallet falls out and a house platen takes its place. Goods that are supplied loose must be assembled into platen loads by hand. The platen loads are then readied for acceptance into the system. Further along the input conveyor, each load is checked for condition and description, which, if necessary, is corrected before it is weighed, and details of the platen load are keyed into the computer. The platen then enters the input loop. In this way, the computer is informed whenever new stock arrives, and this information is stored for use in the clerical activities, as well as for real-time control of the center. All the conveyors and other devices are hydraulically operated autoplat mechanisms. The input conveyor is arranged as a loop. Turntables at intervals serve spurs that run to the base of elevators leading to the high user racking. In the computer, there is a model of the system in which each section of the system is assigned a record in a core store. When a platen is keyed in and enters the input loop, the details of the load are placed in the appropriate place in the disk store. As the platen moves on, the record is transferred in the core store. In this way, the computer needs only to be informed of the position of a load, the nature of the goods on it being found automatically at any time from the records. As a platen proceeds around the input loop, the computer is informed automatically of its movement. At the appropriate point, a turntable moves and the platen travels along a spur, up an elevator, and into the racking. At the head of the elevator are buffer stores where 3 platens may await transfer to the racks by means of the stacker cranes. The high user racking consists of 12 racks interspersed by 6 aisles, each of which is served by a crane. The racks are arranged back to back so that each crane serves the racks on both sides of an aisle. Total storage capacity of the racks is around 2,500 platens. In the computer, a model of the racking is held in the core store, indicating whether each rack location is full or empty. Details of the goods in each location are carried on magnetic discs, as before. New loads are directed to vacant positions in the racks at random. On receipt of a command from the computer, the stacker crane goes to the head of the elevator, collects the load, and transfers it to an appropriate place in the racking. The core store is then updated. Retrieval works in reverse. Shortage of a line at a picking face causes the computer to signal a crane to collect the wanted platen and deposit it in a buffer store at the head of the elevator. The load is then lowered to the carousel. This is a carousel. It consists of two horizontal conveyors, one above the other, and moving in opposite directions. They are connected by elevators at each end. These elevators are the same as those used to service the racks. Empty platens are disposed of to the empty platen storage and retrieval system. The full platen is then placed on the carousel. During a gather, the carousel makes half a revolution, bringing the platens on the lower level to the upper. Picking takes place at both ends of the carousel. As the position of all the goods on the carousel is recorded in the computer, picking can take place in any order. There are 12 high-user carousels arranged in 3 groups of 4. Each line appears on one carousel only. 6 pickers are employed, 3 at each end, with 1 picker attending to a group of 4 carousels. Each man has a picking trolley which he drives to each picking face in turn. Picking is carried out in gathers lasting 2 hours, during which all the orders for 30 shops are completed. Picking starts at one end of the group of 4 carousels, and all the cartons required are picked from that carousel before proceeding to the next. When the carousel is moving, doors close across the picking face. As a door opens, a numerical indicator shows the picker the quantity of goods to be picked. Then, as each carton passes along the conveyor, it is detected and the numerical indicator reduced accordingly. When the pick from one carousel is completed, the operator moves his trolley to another opened position and continues with another pick. It may happen that a platen becomes empty before a pick is complete. Each operator has a console from which he can communicate with the computer. In this case, the operator signals to the computer and proceeds to the next line. The computer notes the incomplete pick and continues where it left off. In due course, the replacement platen arrives. Cartons travel by conveyor to the dispatch department. First, several streams of goods from the picking face are combined into one stream by a mobile sorting conveyor called a shuttle. The order of goods passing to the shuttle is carefully sequenced by the computer so that, as they emerge on the tilting slat conveyor in the dispatch department, sorting into orders for the shops can begin. Each assembly table represents a shop, and the goods required in its order are built up there. As the goods move along the slat conveyor, the computer instructs the mechanism to tilt the slats and so tip the required quantity of cartons onto the appropriate assembly table. The goods, now segregated into orders, travel forward on the table to the front, where they are placed in rolltainers by hand. The required small lines and specials are added to the collection of each order, and the trolleys are wheeled straight into trailers for distribution to the shops. By means of the 4 systems, high user and low user, small lines and specials, the center achieves a remarkably high throughput of goods. Innovation has not been sought for its own sake, but in this application of a computer to control the center, together with the data processing side of the system, lies a significant advance in the technology of distribution and materials handling. The center is no static store, and the time taken for goods to pass from receipt to storage and from storage to dispatch is reduced to a minimum. Improved distribution and better materials handling have a major part to play in economic growth. Modern techniques, like those used in the Regional Distribution Center of the Cooperative Wholesale Society at Berkeley, offer the prospect of substantial economies to those who would use them.